Okay, now y'all are being recorded. Oh, for those of you on YouTube, I forgot to press record. The first Newton's law of motion is a particle will continue to move in a straight line at constant speed unless a particle is acted upon by a net external force. So can anybody give me the second one? Mac, do you know the second Newton's second law of motion?
Not really.
Could you speak up again?
It's like MA, right? Like forces MA.
Yeah, so that's Newton's second law in an equation form. You don't have to raise your hand to speak. Okay, yeah. So say it one more time. Is there a specific way? I'm sorry, repeat that one more time. Yes, there is. So this, I would say, is acceptable. Whenever I took the class, he gave us this definition. Oops. So the acceleration, for those of you that were here last time, you probably already have this, but the acceleration of an object is proportional to the net external force applied to the object and in the direction of the net external force. To me, both of these definitions work well. Basically, as long as you're not saying force is equal to MA and you're writing it in, I would say, a somewhat educated format and style, I would say it's acceptable. Now, Newton's third law, this one I would say is probably the most nitpicky one, just because the definition that they tell you, at least from high school, is just, it's so generalized. So I'm going to go ahead and give you this one. Oh, I don't have enough room. Can you still see? Yes, you can. So if body A applies a force of some type upon body B, then body B must apply the same type of force upon body A that is equal in magnitude but opposite in direction. This is the every action has an equal and opposite reaction. So the next two are kind of trivial. They're more like mathy kind of questions. So it says, what is the equation for displacement, velocity, acceleration, both the average and instantaneous, and write their units? So displacement, who can give me the the equation for displacement? How about Raul? Can you give me the equation for displacement?
Displacement equals V naught T plus 1/2 AT squared.
Okay. You're technically right, but that's a kinematic equation. So that would come down right here.
Okay.
But yes, in a technical sense, that is an equation for displacement. But something a little bit more general. Yep. So displacement, which could also be written as x final minus x initial, is equivalent to your change in velocity over your change in time. Can y'all give me an equation for average velocity? How about let's hear from Alex.
Isn't it just displacement over time? Or distance over time?
Yes. Hold up. I think I just made a boo-boo. Oh. That's not correct. That was something else. And this is the average. Who can give me the equation for average acceleration? I'll circle back to displacement. You got it. Okay. Now, actually, just so that I'm not telling you something wrong, yeah, okay. This is all you can put for displacement, because really all displacement is one position, your final position minus your initial position. That's all displacement is. There isn't really another average, and there's not really an instantaneous displacement. But there is an instantaneous velocity, and there is an instantaneous acceleration. I'm going to butcher this name, but Vianney?
So you want the instantaneous per velocity,
Either one, whichever you can give me.
or for? I know the acceleration. That's like that's the derivative of velocity, right?
Yes. So the derivative of velocity, which is written as dv over dt. You can also rewrite this as the limit as delta t approaches 0 of delta x over delta t. But these mean the same thing. Monday? Yes, instantaneous. Yes. These are average. These are instant. You can give me the velocity. How about Rafael? Right? Okay. Can you give me the instantaneous velocity? No. The integral of acceleration. That is true, but that's not really the instantaneous. So, well, I can't really say that either. Not integral. Not integral. Not sure? Okay, so it's basically going to mirror this, but not using velocity. And I just realized I think I made another mistake. That's supposed to be velocity. Yes. Which is also equivalent to the limit of delta t approaching 0 of delta x over delta t. This is, I don't want to tell you this because this isn't necessarily right, but if it helps, kind of like think of d as in delta. The d does not stand for delta, but if it helps you remember, kind of just remember that d for delta. Okay, so kinematics. We already got one down. Who can tell me one of the other two? How about from Mac?
Give me 1 second. I'm still writing it down.
Oh, okay. So then somebody in this room. delta x equals say what you said again? Velocity plus no. So what did you say? Yeah, delta x. Just so that I guess this doesn't confuse you, this doesn't have to be delta x. This could be delta y. This could be delta z. I just like to use delta x just as for everything, but that x could be replaced by any like axis. And then there's one more. I think this is the one that you were trying to say. And yes. Vf equals V naught plus AT. There are technically 5 kinematic equations, but these 3 can, as far as I know, can solve all of your kinematic questions. Yes. Oh, I totally forgot to answer the second part. This is meters per second, and meters per second squared. Just out of curiosity, what are the units for force?
Newtons.
Yes, newtons. Yeah. Okay, now this is I think this is the last warm-up question. Yeah. What must there be to use the kinematic equations? Yes. So they said constant acceleration. So say if you have a question that gives you like a function for acceleration and it says acceleration equals 3t squared, you can't use kinematics because depending on your time, your acceleration is different. Okay, so that concludes the warm-up problems. Let's get to the back. I kind of tried to start it, but didn't actually go through with it. So the question reads, let me just focus this up. The position of a particle moving along the x-axis is given in centimeters by x equals 10 plus 0.5 t cubed, where t is in seconds. Calculate the average velocity during the time interval t equals 1 to t equals 2. Any ideas on how to start this question? The derivative of position. Why would you say that? Okay. So, and then giving the derivative of position, what will that give you? Taking the derivative of position, what does that give you? Yes. So somebody in class said take the derivative of position. So if you were to do that, you get derivative of 10, which is 0, plus 0.5 t cubed. That is going to give you, I want to say 1.5. Yep. 1.5 t squared. Okay, so, and this is equivalent to your velocity. Now, what do you think you need to do? Okay. So somebody in class said put T2 into the equation and T1 into the equation. So just for clarification, which equation are you putting it into? Okay. So let's do that. So we get V of 2 is equivalent to 1.5 2 squared. 2 squared is 4. 4 times 1.5 is 6. I probably should have brought my calculator out beforehand. And then V of, what is it, 1? Equals 1.5 times 1 squared, which is equivalent to 1.5. What are you going to do with this? Subtract them? So am I doing 6 minus 1.5 or 1.5 minus 6? Why is that? Yes, so it's final minus initial. So the equation for average velocity is delta x over delta t, which is did I write that right? I'm an idiot. So you did not have to do that. So the equation for average velocity is delta x over delta t, which is x final minus x initial over t final minus t initial. So doing all this was not necessary. Yeah. So what they said, what someone in class said is that you're going to take the 2 times, put them into your position equation and not your velocity equation, and then take your final minus initial and do the same thing with your time. So what do you mean? Not really, because what you're doing here is, so what we would have done is gotten our average acceleration. So x1, x2 equals, that can be 10 plus 0.5, 1 cubed. 1, that's 0.5, that's going to be 10.5. 10 plus 0.5, 2 cubed. 2 times 2 is 4, times 2 is 8. 8 times 0.5 is 4, that's 14. Put that into this equation, so we get 14 minus 10.5 over 2 minus 1. So that's not going to matter, that's going to be 1. 14 minus 10.5, it's like what, 2.5? 3.5? Oof. Okay, so I also made another mistake. So in the question, Okay, so in the equation, it gives you position in centimeters. Now, technically, you could just put in centimeters over seconds, and that'd still be technically a correct answer. But typically, we want things in meters per second. So if it asks, like specifically, put it in meters per second, could somebody tell me how to do that? How about from Raul?
Oh, you said the 1 meter on top and then on the bottom 100 centimeters in order to get meters.
Mm-hmm. So you're going to divide by 100. That's going to move this decimal place over 2 times. So you're going to get 0.035 meters per second. And if you're clever enough, you could also just write it as 3.5 times 10 to the negative 2 meters per second. And that would also be completely fine. So that's all for our average velocity. How about instantaneous velocity at 2.5? Can Alex tell me how to do that?
Don't you plug in 2.5 to the derivative of x? So it's plug in 2.5 to 1.5 t squared.
Yes, sir. So you get v of 2.5 is equivalent to 1.5 of 2.5 squared. That's going to be 9.375 meters per second. And that's how you solve that. This is a standard, I want to say chapter 2 question. On your quiz Wednesday and your exam next Wednesday. From what he's told me, it should go over chapters 1 through 4. So that's anything from unit conversion, that's your average and instantaneous, that is circular motion, kinematics in 1, 2, and I don't know about 3 dimensions, but definitely 1 and 2 dimensions. I know currently in class y'all are like y'all barely touched chapter 6, so that y'all introduced to friction, I think. No? Okay, so y'all are about the end of chapter 5. So throughout particularly this session, I'm just going to cover just earlier subjects. Make sure y'all are golden on those. The next question says, a car starts from rest and accelerates at a rate of 2 meters per second squared in a straight line until it reaches a speed of 30 meters per second. The vehicle then slows at a constant rate of 1.5 meters per second squared until it stops. How much time elapses from start to stop? How would I start this question? Label everything? Okay. So how about again, name I can't pronounce, Vaney? Could you tell me everything that's given in the question?
They give us it accelerates at 2 meters per second squared. And then the speed of 30 meters per second. And then 1.5 meters per second squared.
Okay, what is that 1.5?
That's an acceleration. Oh, wait. Yeah.
Okay, so I'm going to go ahead and write this one as A naught and this one as A final. 1.5 meters per second squared. And then other than that, it doesn't give us anything. Oh, shoot. This notation that I use right here, the absolute value of t, that's another way you can write speed, because all speed is the absolute value of your velocity. This kind of goes back to the idea of vectors and scalars. Vector is a quantity that has both magnitude and direction. So taking the absolute value of a vector gives you a scalar because it takes out the positive or negative and it just gives you a magnitude. Okay, so now we got our givens. How would you go about finding the time elapsed? can't use kinematics? I wouldn't say you can't, but you definitely can't use them like throughout the entire motion. We can use it to find time, but it's going to be kind of like in multiple steps. Mac, do you think you could give like maybe a first step to what you would do?
Sorry, could you repeat that?
So like if you were given this problem from here, what would you do? What do you think you should do? Just to give y'all all a hint, y'all can use kinematics. True A delta X and delta. So you're saying use which equation? Okay, then what are you going to use that for? To find T? Okay. So, okay. So how I like to approach kinematic questions is with a little table. So I'm going to get to your step in a minute. So since this equation, or since this question in general doesn't really seem to have multiple dimensions, so it doesn't seem like I'm going like at a diagonal like in X and Y or X, Y, and Z, I can safely assume that this is a one-dimensional problem, and I'm just going to make that one dimension X. So how I like to set this up is V final, V initial, delta, A, T. That's how I like to set these up. If you have a different method that you're comfortable with, go ahead and use it. This is just how I like to set things up. So it gives us an initial speed, but I'm just going to go ahead and put it as velocity. So 30 meters per second. We're going to go ahead and use this initial acceleration, so which is 2 meters per second squared. And let's see. Oh, shoot. I'm an idiot. V naught is 0 meters per second because it starts from rest and then accelerates to this speed. So this is 30 meters per second, and this is 0 meters per second. So what somebody in the class said is that go ahead and basically ignore this and solve for this. So, and he suggested using, I don't know if y'all can see them, but this first equation. So how we're going to do that is set this up, VF equals V naught plus AT. Now, a lot of people like to plug in numbers straight away. I really don't advise that you do that. I know at this stage, at this level, the math is super easy and you can probably get away with it. But as you get on in this course, things are going to get a lot harder to keep track of. And it just makes things simpler to just keep them as variables and put in numbers at the end. So what we're going to do is set this equation to equal T. So we're going to move this over, so it's going to be delta F, or not F, delta V. And then divide that by A, and that's going to be RT. Does anybody have a problem with how I did that? Does it all make sense? Yeah, so like the how I got to t equals v not double v how I got to t equals delta v over a. Does that all make sense? I know I kind of skipped a lot of steps math-wise. Okay, I don't hear anything, so I'm going to assume y'all got that. And then you just plug in. So this is going to be your final minus initial, 30 minus 0, over your acceleration, which is 2. That's going to be meters per second squared over second. That's going to be we're good? Huh? 15 meters per second. Okay. So that gives us 15. Oh my God, that's not right. I'm sorry, you were right the first time. Yeah, because this is meters per second squared. This is meters per second. Yeah, the meters are going to cancel. The second is going to cancel. And the seconds are going to go up top, so it's going to be seconds. Yep, you're right. I'm sorry. Okay, so are we done? No. What is this 15 seconds? Yes. So this time is the time that it took to reach 30 meters per second. We want to know how long it took to both reach 30 meters and then deaccelerate to stop. So this is really only half of the question. You could write down, yeah, like just T1. And say that like delta. Yeah, so that's just like how long it took to reach 30 meters per second. Yes. So this is half of it. So let's set up the second half. X, Vf, V naught, delta A T. So this, we're going to use the second acceleration, 1.5. We'll go ahead and denote it as negative because it is slowing down. So we don't know how long or how far it went. What is its initial velocity going to be? 30. Why is it 30? Yes. What is our final going to be? 0. And then you set it up the same way. You use the same equation. Move it around over A. And then you plug and chug. So this is going to be final minus initial divided by our acceleration. Now that's going to be 30 divided by 1.5. That's going to be 20 seconds. Let's say we're just going to denote that as time 2. And I'm just going to go ahead and write delta t is equivalent to t1 plus t2. T, the total time elapsed was 15 plus 20, 35 seconds. One more time? Oh. Thank you. Does everything that I did make sense? Was there anything that doesn't make sense in my math? I don't see anything. Okay, looks like we're all good. Give you all a little bit of time to copy that down if y'all are still writing. And then from here, this is it for my worksheet. So from here, I set up a Jamboard for us to do. So this is gonna require for both people in class and on Zoom to go on your computers and go to the Jamboard that I have listed on my website. Yeah, it should be on under lessons. Yes. Mhm. Okay. Now, let me see. Lessons. Quiz prep. Oh no. Oh my God, what is this one under? Oh no. Okay, I'm just gonna do it from my laptop. Please tell me I can bring it up on my laptop. Yes, I can. Awesome. So there are, what, 8 people in here? So one, two, three. Oh, wait a minute. I don't have to do that. One, two, three, 4, 5, 6, 7, 8. So was everybody on Zoom able to find it? Yes. Yeah, there should be like a lot of frames now. So I guess let me just look at everybody. Okay, so there's 1, 2, 3, 4 other people online, and then there's 3 people inside. So I'm going to go ahead and just say that 1, 2, 3. So you're all going to be on the first 3 slides. And then Raul, you'll be on the 4th. Alex, you'll be on the 5th. Max, 6th. And I'm so sorry if I'm butchering your name, but Vianney, you'll be on the 7th. Yeah, 1, 2, 3, 4, 5, 6. Yeah, 7. So everybody on Zoom, were y'all able to find the Jamboard? I don't see anything.
Yes, I'm on it right now.
Okay. It's not letting me know if anybody's on, so that's scary. Monday? Huh? Have a code. I do not think, I didn't know I needed a code. um, Just out of curiosity, what's showing up? Okay, that's the old one. Yeah. Okay, you know what? Since this is going to take a little bit, I'm just going to go ahead and take the problems that are on Jamboard and then just write them out on here, because I don't want to take too much time trying to figure that out. Oh my God. I missed a problem on the worksheet. Yeah, so I'm going to go ahead and speed through this, and then we'll start the Jamboard questions. Okay, so if you, okay, so for those of you that are on Zoom, I forgot a question on the worksheet, so I'm going to go ahead and go back to that, and then I'm just going to go ahead and write the Jamboard questions on a piece of paper, and that way both people and then people on YouTube will be able to see them too. Okay. So a ball of moist clay falls 15 meters to the ground. It is in contact with the ground for 20 milliseconds before stopping. What is the magnitude of the average acceleration of the ball during the time it is in contact with the ground? Okie dokie. So I'm just sorry for moving all everywhere. Anybody have an idea on how to start this question? I admittedly do not know off the top of my head. How I like to start problems is by drawing a picture. So I'm going to go ahead and draw a picture. Let's say this is a ball of clay. Just say that's delta y, which equals 15 meters. And I guess draw like another kind of picture. Contact. That's not how you spell contact. With ground for 20 milliseconds. Okay. So somebody in class said use this equation. So just to be sure, I'm going to set up my table. This doesn't appear to be multiple dimensions, so I'm going to assume it's just the one. VF, V naught, delta A, T. I guess I probably should have asked y'all this before I just went ahead and wrote it, but this is a kinematics equation. I mean, a kinematics question. What is V naught? 0. Somebody on Zoom, can any of y'all fill out a second box or a second little letter?
Acceleration is 9.8.
Okay, acceleration is 9.8. I'm going to go ahead and write that as G for now. Off the top of my head, I want to say it's positive, but if I'm being honest, I'm not 100% sure off the top of my head. So I'm just going to write it as a positive 9.8 and a positive G until I can make a better judgment. Can we fill out any of the other boxes? Time? Yeah. So let's hold off on time. Delta is 15. Okay, and then that's about it. There really isn't anything else we can. Okay, let's start with V naught. So V naught is 0 because, I mean, let me see. Yeah, so yeah. So like unless it says like it was thrown out of initial velocity as this, you're supposed to assume that it's just a free fall and it has an initial velocity of 0. Okay, so 15 is because its entire distance it travels is 15 meters. So like in the first line it says a ball of moist clay falls 15 meters to the ground. Okay, so now from here, what is the magnitude of the average acceleration? Well, actually, I'm not even sure if this is kinematics. Now that I read it again, because it says average acceleration, and the equation for average acceleration is, can anybody tell me? Oh wait, y'all can't even see. Somebody said it, it's delta V over delta T. So, So this is kind of an interesting question. And I think it's going to take acceleration up or down. Okay. We have an initial velocity. We have technically an initial time, so that time equals 0. What is the average acceleration of the ball during the time? And okay, during the time it's in contact with the ground. So you were right in the beginning to say that it is 20 milliseconds because it's the contact with the ground part. That's going to change a little bit of things. Can't say this anymore. I don't even think we can say this either. Okay. I'm gonna be honest, I'm a little stumped. Okay. Not necessarily, because v final, we usually dictate v final as the velocity just before it like touches the ground, so it's maximum velocity. If so, okay, I'm gonna set this up again. So this is v final minus v initial over t final minus t initial. This is going to be 0 minus 20 milliseconds. So we have this initial. Okay, I think I know what you got to do. AT. So I shouldn't have erased that. So, okay, I know what to do. I'm going to set everything up like we had. Okay. We do not know initial velocity and we do not know final velocity. Now the reason why, well, at least for this, because we do not know from what time interval that it's in contact with the ground. So we do not know at what velocities is it in contact with the ground. So we need to find them. We're actually going to start by finding V initial. And we're going to do this by solving for V final, if I'm not mistaken. Just to check myself, I think I'm going about this correctly. Equals V naught squared plus 2a delta x. Because once it's going to reach in contact with the ground, it's going to start deaccelerating. So this final velocity is going to be that velocity right before it touches the ground. So yeah. Mm-hmm. So somebody just asked if we're trying to find that instant, so that time from where it initially touches the ground to where it like squishes and reaches 0, which is exactly what we're trying to do. So this final velocity is going to be that initial velocity from where it first contacts the ground. So just move it better in focus. Square root of V naught squared, which is this is going to be 0, plus 2a delta x. Okay, so so from here we're going to plug in. So VF equals square root of 2 times 9.8 times 15. So, Now, whenever you're in a test, you're probably going to start questioning about your positives and negatives. So when is 9.8 positive? When is it negative? And if so, like say if I were to make this 9.8 negative, that would make this an imaginary number. So the way that, unless, other than by just like understanding math-wise, the way that I like to do it is setting up your coordinate axis. So whenever I'm falling from the top down, I set up my axis like this, with y being down and x doesn't really matter because we're not moving the x. Now, whenever I do this, this is going to be positive and this is going to be positive because I'm starting at y equals 0 and ending at y equals 15. So final minus initial, 15 minus 0, it's going to be that. And then acceleration is going to be positive because I'm accelerating in the positive direction. Now, you could do this and flip your axis and to have your axis up here with up being positive and down being negative. And then both of these would be negative. And then they'd cancel. So either way, it works. It's just a matter of how you set up your axis. So VF equals the square root of all that nonsense. Is that before or after the square root? Okay. So it's 17 what? Okay, so that's what the people in class came up with. Okay. Yes. That's kind of hard to say. If it was a paper, like just in class, I would say it doesn't really matter. I would say just round to the nearest hundreds. If it's online and you're doing the thing online, I would say be So what you're supposed to do with sig figs is however many sig figs is the most accurate number in whatever the question is. So in this case, it would be 2 sig figs. I would just put 17. But from how I understood and from whenever I talked to Dr. Marble about your quiz this week, how I understand it is that I'm assuming he's probably going to have like some sort of PDF, I guess, and upload it. And then all of y'all can take it at once. And then he's going to have y'all be on Proctorial. So he's not going to let, so basically what that software does, if you haven't had it yet, once you start it, you're not going to be able to change tabs or anything. So you're going to be able to be on that one tab, which is, I'm assuming, the test. And he's going to have y'all position your camera so that he can see like your hands, your calculator, your paper, your pencil, whatever. Just to prevent y'all from cheating, which I know y'all won't do. I know from personal experience, because although I have never had them with Rona, but from personal experience, how it worked is during class, so the test was broken up into 2 parts. So there was an in-class part and a lab part. So the in-class part, it was basically more of like definitions and what are the units for this, who is this, or who is Newton, why is he important. I honestly don't know how he's going to do it now. The quizzes, I would say, is more similar to your homework. So if you want to practice, do your homework. The quizzes, the exams, though, those are a little bit different. There's a portion that's the open-ended part, which is exactly almost like your homework. And then there's the in-class part, which is more like definitions and stuff. So if it's going to be 3 hours, that's probably just going to be during your lab. I don't know how long y'all's labs are. Are they like 2 hours? 3 hours? Okay, so then it's just going to be, yeah, so it's probably just going to be during lab. Okay. So, okay, and going back to the question. So we have a final velocity, which is this initial velocity. Now we need to solve for this. Well, we actually already know that it's going to be 0. Because by the time it's fully squished, it's not moving anymore. So from how I understand this, so 0 minus 17.14 times your 20 milliseconds, so that should be what? 20 times 10 to the negative 3, I want to say.
Did you reverse the 3 to solve for VF, and then you just said VF was 0?
Yeah, so this VF is this V initial.
Oh, okay.
Yeah. Yeah. So the V initial, so this V final is right before it touches the ground, which is the exact same as this V initial, which is whenever it initially touches the ground. Because what we're solving for is the average acceleration of the time whenever it's in contact with the ground. So it's just those last 20 milliseconds. So putting that in, that is 17.14 divided by 20 times 10 to the negative 3. I get 857. And that should be meters per second squared. Negative, because it's deaccelerating. Does that make sense to everybody in Zoom? Y'all are able to see everything, yeah? How come it's negative? It's because it's deaccelerating. Okay, I don't see any questions, so I'm going to assume y'all got it down. So since Jamboard was not working as well as I thought it was going to, I'm going to go ahead and work out the problems that were on my Jamboard just on paper. Okay. So the first question is, vector A equals 3 I hat plus 3 j hat minus 2 k hat. B is negative 1 I hat minus 4 j hat plus 2 k hat. Then C is 2 I hat plus 2 j hat plus 1 k hat. The first part asks for A vector dot B vector cross C vector. Okay. Alex, can you tell me how you would first start off this question? Oh no.
I guess I would take the cross product of B and C, and then
Okay.
yeah, that's what I'd do first.
Okay, yeah, that's exactly what you do. So you treat these exactly like you would any other generic algebra problem. You do PEMDAS. So you work with the parentheses first. So let me ask someone else. Mac, can you tell me how you set up a cross product? I'll wait for him. Yeah, yes, you're right. But let's see if Mac, do you know how to set up a cross product?
Oh, I didn't hear you. I didn't.
Oh, so how would you set up this cross product?
So you take the for B, you would be the I of B, then the J of B, and then the K of B. So cross like that, and then
Or let me do this. This is an SI session till 6.
and then well, I guess it's B and C because then you put once you put right below that, you would put the I, J, and K of C.
Okay. Let me see, just out of curiosity. Okay. Okay, I'm going to have to cut this session short. No, it's fine. So just to speed through this, just because I know cross product is a pretty important part of the test. So what you're going to do is 2, 2, 1. You do cross. So I'm just going to call this BC vector. Minus 4 times 1 minus 2 times 2 I hat. Then it's going to subtract, cover up the next one, negative 1 times 1 minus 2 times 2 And then you're going to add -4. Did I do that right? Nope. -1, 2, minus -4, 2. And then so this is going to be your I hat, that's going to be your J hat, and that's going to be your K hat. And you're going to do all the algebra. You're going to get 3 components, I, J, K, and then you're going to dot it with A. Just if y'all want to do it on your own, I think the answer that you end up getting is 21. After you do all your math. So yeah, I'm gonna have to cut this short. I don't really have a lot of time for questions. You have you have your quiz this Wednesday, which you could do at any time of the day. At least that's how he told me. And then you have your big exam coming next Wednesday. I will be holding another test prep next week, probably on Monday because it's going to be on Wednesday. And I'll see y'all guys then.